Hey guys, this React tutorial is brought to you by Linode. This is the company that I use for all my hosting, and they've been around now for 15 years. They're the largest independent cloud provider available. They saved me a ton of money over Azure and AWS, and honestly, I have tutorials on how to get everything set up as well. So you have everything you need with Linode, and you also get a $20 discount, which is in the link in the description tab below if you go ahead and sign up for them. Again, I recommend them very much. Hey guys, what's up? So in this video, we're going to be looking at React and how to get started with it. I'm about to release a video here in the next couple days that actually looks at all the different statistics and why you want to learn React and which one's the hottest client-side framework. And long story short there, React is the #1 client-side framework right now in late 2019 going into 2020. And if you're looking to get a job, this is one of the easier ways of actually getting a job, although React is not easy at all. And you'll see the more complicated the architecture or the UI, depending on how sophisticated the website is, how many components. It's all going to follow a React principle for a component-based architecture. And although the basics are very easy, when you start getting into huge apps, they're made up of literally hundreds to thousands of components. And those components are interacting with each other through all kinds of different means. So whether that's like some sort of AJAX call to a server, which means a network request to a server to get some data, every app is going to be different. But one of the great things about these client-side frameworks is that React has a specific way of doing things. So if you learn the React way, then you're going to be pretty well versed. Even if the architecture itself gets really, really complicated. So if there's thousands of components, once you start getting the idea of how these components are interacting with each other and how they're re-rendering, then it all starts to become a little bit more easier to deal with. Although I don't want to like sugarcoat it. React is something that people get paid a lot of money to do. So the average React developer is making roughly $120,000 a year right now. And there's a reason for that. It's not exactly easy. So you could follow a tutorial and be like, oh, I think I have this under my belt. But it's going to take more than that. So what you're going to want to do is you're going to want to follow along with this tutorial series to see how to get up and running with React, how to build your components and your UI architecture. And then from there, what you need to do is go ahead and start building your own project. So take whatever we're going to discuss in this video and then just kind of redo it over and over again as you build out your own websites. And as you build your own websites, you're going to quickly get up to speed. And if you can do that, a lot of people ask how long is it going to take and things like that. But I don't really have the answer for that, but if you're pounding out React code day in and day out and you build a relatively complicated website, whether it's like something like YouTube or an Instagram type of thing, then 6 months of doing that, you're probably going to be you're going to be pretty good to go. You're going to be able to probably get a job in React doing some basic junior level development stuff. So I'm not going to waste a bunch of your time trying to like explain all the different tools and like what they're used for and all this stuff. Like a lot of tutorials do that, but I will say the editor that we're going to write our code into is Visual Studio Code. A lot of you guys have probably already heard of that. Node.js is going to be required in order to install all of our tools, and our web server itself is going to be a Node.js web server. And then as far as TypeScript is concerned, this is basically JavaScript, but it's JavaScript in another way. And TypeScript itself is called a superset of JavaScript, which means that you write TypeScript code and then you compile it using Node and it turns it to JavaScript. And it's going to all be done automatically, so you don't really have to know the inner workings of how that works. But TypeScript is something that you definitely want to add to your resume, just like React. And they kind of go hand in hand. And although there's a pure JavaScript way of writing React, you still have to install a bunch of stuff, so we might as well just jump right into TypeScript because that's also something that a lot of companies are looking for. Now, I'm working on a Windows machine, but it doesn't matter if you're on Windows, Mac, or Linux. All this code is going to be the same, although the commands to run the code could vary slightly. If you're on Linux or Mac, then you're probably going to have to run the sudo command to actually execute to make sure you have permissions to write files and things like that. But you're probably already familiar with that as well if you've done any sort of development on a Mac or a Linux operating system. To get started with Node, you just want to go to their homepage, their website, nodejs.org, and then go to the downloads and whatever sort of operating system you're on. Make sure you have that installed. To test that you have it installed correctly, you can pull up a command line or a terminal. And if you just simply type node, then it's going to, if it pulls up this command line, that's the node interpreter. And Control C gets out of that if you press it twice. And if you wanted to see the version of node that you're on, I can type node -- version, and I'm on 10.15.3, but you can be on a newer version or even an older version. It's probably still going to work just the same. All right, so whenever you're starting your own project, what you need to do is figure out, where is this new project going to sit on my computer? Because we're not going to put it on a server or GitHub or anything for right now. Although the code that I write for this, I'll go ahead and have it on GitHub so you guys can, if you don't want to mess with the configurations, then you can just go ahead and clone the project and go from there. But I think it's helpful to go through the configuration process, so we're going to do that in this tutorial. And I put everything in my projects folder on the C drive, and I created a folder called Total React Tutorial, which is what this tutorial is, because we're going to totally cover React so you guys can get a job. And you can see it's just an empty folder here. So what I want to do is, after I install Visual Studio Code, you're going to want to open up the editor to whatever folder it is that you just created. So hopefully if you just follow right along, just put Total React Tutorial, and I have that sitting in my C drive under my projects tutorials folder. And then I'm going to select this Total React Tutorial and say select folder, so Visual Studio Code will open up into that folder. Now by default you should have the Explorer open, and if not, just click on this this icon here, and you can click it to make it go away as well. But if you click on that, that's going to show you all the files that are sitting inside that folder, and right now there's nothing there, so it's just an empty folder. So make sure you have the project Visual Studio Code opened up to that folder that you created that you want to put your code into. All right, guys, so now that we have the project folder created and we're ready to actually start writing our code, I just want to go ahead and explain a little bit about React's overall architecture so you guys know. And if you go to React's home website and if you're using Chrome, and this is actually the browser that I recommend for your development because it has some of the best developer tools that you can use to make it easier to understand what's going on with your React code. If you're in Chrome and you go to the React website and you just right click on your mouse and say inspect, it's going to open up something called the developer console. And inside of here, there's a lot of information, but right now you're probably not going to have this option called components, because this components option is an extension in React or in Chrome actually that allows you to debug and look at all your different React components. And if it's in a React application, this extension is going to show all the different components that you have. So in order to install that, you need to go to your Chrome web store, and it's free, and you're just going to type in, make sure you get to the extensions of your Chrome web store, and then type in React. And this is there's going to be a React developer tools, and you're going to want to make sure that you install this on your machine. And then once you have it installed, it's going to show up here on this. It's going to be one of the panels or tabs on your Chrome developer tools. So this is going to have all the different components for your React application. And right now this is a little bit too difficult to really grasp here, but these are all separate React components. And that kind of brings me to my next point, is that when you're doing React development, there's going to be one core component that is it's like a tree structure, where at the top of the tree you're going to have your overall main React component, and then everything else is going to be components that sit inside of it. So your components within React can be everything from like this entire banner right here, which is sometimes called like a jumbotron. Buttons themselves can be React components. Even simple radio buttons and other HTML elements can be made with React components. So a React application is going to have all these different components, and ultimately though, it's all one main component that holds all the components on the inside of it. So you can think of your main component as like a Christmas present, and then it's just comprised of a bunch of different little presents inside of it, and kind of like those German dolls that pop out. That's the same kind of thing with React. So you're going to have one component. And the reason for that is because React is all about re-rendering the HTML on your page when certain data changes. So the overall component can listen for any sort of changes that are made to it. So if you pass data to it, all its children components, all the components that sit inside that main component, and it doesn't have to be just, there's always going to be one main, but then you can have like a child inside that main component, and then that component can also have a bunch of components inside of it as well. So that's the way you need to look at the overall React architecture. So I know that's really hard to grasp, especially verbally, but as we start developing this stuff, you're going to see that it makes more sense. The more you develop it, the more you're like, oh, okay, I understand that. Yeah, this is a child component, there's a parent component, and on and on and on. But ultimately, there's one main component that's going to render your entire application. All right, guys, so let's go ahead and create our project. And what we want to do is go into Visual Studio Code. And when you right click inside your Explorer window here, just say Open in Terminal. And what we're going to do is say npm, and this is included when you install Node. And you're going to say init, which is short for initialization. And this is going to create a new project. So we're just going to call this React Tutorial as the name of it. I'm going to make this a little bit bigger so you guys can see it. All right, so this first command is going to be React Tutorial. It's going to be version 1.0. And we'll just say a React Tutorial by Chris Hawks. All right, and then this is the entry point to our application. Right now, we can just keep it index.js. That doesn't matter. And you can put your own name here. I'm going to put my name. And the license, it doesn't really matter. That's for if you want to distribute your code. You can do like an MIT license if you want it to be free. Once you do that, though, it's going to create something called a package.json file. And this is going to be what is actually keeping track of all the dependencies that your project has. And what a dependency means, it really just means my project needs this, this, and this in order for it to run. And it is handled automatically for you. So you'll see in just a moment when we install React into this, it's going to keep track of what version of React we're using, and then also any other tools and plugins that we decide that we need for the application. All right, so let's go ahead and look at how we're going to install our tools. So what we want to do is right click, say Open in Terminal from within this Explorer window, and this is going to pull up the terminal. It's going to open it up to the folder for your project. We're going to say npm install and then -- save, or you could do, we'll just do -- save. And here we're going to say React and then React DOM. Those are two separate projects. React is the actual React architecture, or the overall core code for React. And then React DOM is actually what is a separate project for dealing with HTML and rendering things to your browser. And the reason why it's a separate project is because React has now gotten into virtual reality with React VR. And also there is React Native for mobile app development. So once they started branching off into those other things, they decided, okay, React for HTML and web pages, it needs to be its own separate project. And that's why React DOM was created. So we're going to go ahead and install those two. And if you press enter, this is going to reach across the web, and it's going to add these to your package.json as a dependency. So now you can see the specific version of React that we're referencing in React DOM. So even if you're watching this video at a later time, it might be a newer version of React. But so far, React has been backwards compatible. So even in the future, a lot of this should be the same, even if React and React DOM have a different version number to them. All right, guys, so the next thing we need to do is we need to install TypeScript. And because TypeScript is going to be something that we're using for development, it's going to be under a different category called developer dependencies versus regular dependencies, because we don't need, if it's a dependency, you need that project or that plugin, that code base, you need it in order for your actual website to run. But if it's a developer dependency, then it's just a tool that's helping you write the code. So because TypeScript is really just writing JavaScript for us, it's considered a developer dependency. So we're going to say npm install or just really -d for developer dependency, and then we can just say TypeScript. So now that we've done that, you can see that TypeScript is showing up under a different category, like I mentioned before, which is developer dependencies. And again, it's because TypeScript's not needed for your project to run inside of a browser. It's just simply an easier way of writing your JavaScript code. Now, this is not a TypeScript tutorial, and although we're going to touch on a lot of different TypeScript, there's going to be separate tutorials that you're going to want to reference for TypeScript. You can look at some of mine, and I'm going to be creating some in the future, but you can also go to my buddy Brad Traversy. He's got stuff on TypeScript. And overall, TypeScript is something that we're going to be using. You don't have to be an expert in it, so even if you don't know TypeScript, you don't have to stop the tutorial. You can actually learn TypeScript while you're creating your React application. But TypeScript uses something called types. And they're types that you can define that basically say, hey, this type has a bunch of, like, let's just say if type is Chris, then he has something called a head or a body or legs or something like that. And each one of those head, body, legs, they're defined as a specific type. So TypeScript's all about basically enforcing contracts to say, hey, you want to implement code this way, then you need to actually have you need to meet all of the criteria so that that code works. And TypeScript tries to protect you from making errors within JavaScript that's going to end up only showing up when the application's actually running. So TypeScript, if you don't have everything in line, it won't create the JavaScript for you. But that's a good thing because you don't want JavaScript that's going to run and halfway through, like uploading a form or something like that, it breaks. TypeScript's going to warn you of something like that at compile time as you're developing the application, so your customers don't have to see that error message themselves. And that's really, in a nutshell, what TypeScript's doing. It's all about just trying to make the code much easier to reason about and understand, and also to prevent those errors from occurring later on down the road. So there are separate projects that are created already for us that allow us to use types within React and React DOM, but we need to go ahead and install them. And again, it's going to be a developer dependency because it's TypeScript related. So we're going to say at, and here you're going to say types and then React. And then we're also going to do a space between that and say types and then React DOM, since they're two separate projects. And this is going to install all those types that we need for both of those projects. And you'll see again, it goes under the developer dependency and not the normal dependency. Because when the application is in the browser, it's going to need these two in order to run. And these three just help us actually write the code. All right, guys, so what we need to do now is we need to go ahead and tell our TypeScript compiler how to behave. Every TypeScript file or project is different, and there's all these different settings that you can tell TypeScript to do. So you can say, hey, TypeScript, I want you to turn this JavaScript to more modern JavaScript that might only work in certain browsers, like the newer ones. Or you can say, you know what, I want you to turn it into old JavaScript to make sure it works all the way back in like IE 11 or even before that. So that is an option that we can do with TypeScript, which makes it really helpful. But in order for TypeScript to know about that, we have to have an actual configuration file for it. So we're going to right-click in our Explorer, and we're going to create something called a tsconfig.json, which is JSON file. And this is just a JavaScript. JSON stands for JavaScript Object Notation, but you guys don't really have to know about that. But it's a bunch of key value pairs. And you can see like compiler options is an option that I have. So I'm going to go ahead and just tab on that so it'll create it for me. So there are a ton of options that we can give to TypeScript, but for right now, what we want to do is we're going to go ahead and define something called our module, and we want to use common JS as our module. And then there's another option for JSX, and JSX is a JavaScript XML type thing if you want to be exact, but basically it's how React creates HTML elements, and we're going to be using JSX. So the version of JSX that we're going to be using is going to be just standard React and not React Native. So make sure we add that. Also, when we do a build, we want to add a watch. So instead of having to run the build over and over again, a watch that equals true is going to continually listen for any sort of changes to your TypeScript files. And every time it changes, it's going to recompile without you having to run the command. So that's what the watch is doing. And then the target The target command is something where you could say, I want to use older, like IE 9 or 8 or whatever. That's probably ES3. I don't really know, but we're going to say ES5, which is mostly working in everything from IE 11 and up. And then the last thing is we want to go ahead and say a lib command, which is for library. And we want to say the different types of libraries that we want to use within TypeScript. So if we want to write modern JavaScript or really TypeScript, we want to say ES6 in here, and then we're going to say DOM. So this is just a JavaScript list of two different values in here. So ES6 and DOM, and then make sure that's in there. Press Control S to save it. All right, so what we're going to do now is create our first TypeScript file. And what we want to do is put that, we're just going to put it right in our root directory, but we're going to call it index.ts, which is the TypeScript file extension. And here what we want to do is put in some modern JavaScript in here. So we're going to use a constant variable that says my name equals, and then we're going to put my name in here. All right, so every statement in TypeScript should end in a semicolon. And that's just like regular JavaScript. Now, constant is not actually supported in older browsers. So when we actually go to compile this TS file, it's going to create a JavaScript file for us, but it's going to change that constant to something that actually works in an older browser, which is just a simple variable. So it's going to change it to var, but we'll see that in just a second. Go ahead and click back on your package.json file. Inside your scripts here, we're going to go ahead and create a command that we'll be able to run that's going to go ahead and compile our code using TypeScript. So in here, we're going to create a build and then put a colon. And then here we want to say TSC, which is short for TypeScript. And then we'll just go ahead and give it the name of our starting point. So we want to say, when we execute this build command, we want you to find the index.ts file, which is right in our root directory, and we want you to compile that. Now, every key value pair inside this JavaScript object needs to have a comma, so make sure you have a comma there, and that error message will go away. Now, let's go ahead and try to run this build command that we just defined in the package.json. So right-click and say Open in Terminal. And we're going to say if we want to run this command in our scripts, and this is actually a very common thing that you'll see with all modern TypeScript, and not even just TypeScript, really modern Node.js projects. So anything that uses Node, even if you didn't want to use TypeScript, you're still going to run into similar things like this. And this is just something I don't expect any beginner to know, but like if you just follow along, do it over and over again, eventually you'll be, you'll get your job and you'll realize some other company's doing it the exact same way. So I know a lot of this doesn't really make a whole lot of sense, and like I don't expect it to, but the more you do it, the more that it will. So to run this script, we're going to say npm run and then the name of the script. So if I said gobbledygook or something, like it could be whatever you want. In our case, we wanted to say build since we're going to be compiling the project, so we want to build it. So when we say npm run build, this is going to go ahead and create a index.js file, and you can see we'll touch on this this error message in just a second, but you'll see that the index.js file was created for us from the index.ts file. So you can see that, just like I said, it went from a constant to a var, so that way it works inside older browsers, and that is TypeScript working for you. It actually took this modern JavaScript code, TypeScript code, and it turned it to an older version of JavaScript that will still run in the very old browsers. All right, so going back to this error message, if you guys are seeing this, this is this is something related to Node itself and types. And in order to fix this, what we need to do is we're going to say npm install types node. So just like we did with both React and React DOM, we have to do the same thing with Node in order to resolve that problem. All right, so you'll see if we go back to our package, we went ahead and we installed these types node, and this is actually a dependency as well. It could have been a developer dependency. In fact, if you ever make a mistake, let's go ahead and touch on that. We're going to say uninstall at types node. So if you ever made a mistake and you accidentally installed something you don't want to, npm uninstall will fix that. So that will fix that. And let's go ahead and do the same thing again at types node. But then we can say -d for developer dependency. And it's always good to separate out your developer dependencies from the actual dependencies needed in order for the thing to run inside the project. So basically your finished project needs these in order to run, but these are all needed just so you can develop. So let's go ahead and try to run the build command again. If you just press your up arrow, it should go back to your original statements you entered earlier. And hopefully that error message now goes away. And you can see that it did. All right, so it went ahead and created this file, didn't give us any error messages that time. All right, so I just wanted to explain the actual compilation step that occurs when you're dealing with TypeScript. What I want to do is go ahead and delete this file here, this JavaScript file, and we're now going to create a folder called our source. And by default, every project is going to have a source folder, which is going to contain all of your TypeScript code. And we can just drag the index right into the source and say move it in there. And now by running this command, it's going to automatically look for that index inside the source. So if we run build, it's going to read the configuration file properly, and you'll see that it actually tries to watch it. However, you can see that it says it does not find the index.ts. So these error messages are always pretty common. We need to go ahead and change our package.json where we said, hey, try to find the index.ts in the root folder. Now we're just simply saying run TypeScript, and by default, TypeScript's going to look inside the source folder. So I like to include these error messages in here. And honestly, as they come up, these are things that you're going to end up running into all the time. So it's best to see them now. Now, what you can see is that we are watching the file. So if I were to change this, let's just look at the compiled code. It's Chris with a var here. And if I were to just change this on the fly to say on the fly and press Control S, you can see that it detected that there was a change. It recompiled. And if we look at the JS, you can see that the variables changed. So by default, TypeScript is going to look inside the source folder, and it's going to compile all of those files and just build them as you change them from now on. So let's go ahead and do an alert statement in here so that we can alert the value of my name. And you can see again, Control S, it recompiled. And if you look inside here, it's all compiled now. So let's go ahead and create a index.html file, something that we can actually view the code from within a browser, because that's what all modern React is. It's running inside of a browser. So we need to go ahead and create an HTML file for that. So we're going to do that now. Every HTML file is going to have an HTML opening and closing tag. It's going to have a head. And we're going to say our project inside the title of this thing. And then we need a body. And you always want to load your JavaScript code like just above the closing body tag. That way it's considered non-blocking. And that's something that is going to come up a lot when you're dealing with performance and all that stuff, because you don't want your JavaScript to block the loading of the page. It creates a bad user experience, and Google will actually penalize your website for doing that. So you want to load everything, and then at the very end, you're going to load your actual JavaScript file. So here we're going to say source equals, and we're going to point to the JavaScript file that was created. So we're going to say source and then index.js, and make sure you actually point to the JavaScript version of your file and not TypeScript, because TypeScript does not actually run inside your browser. It's the JavaScript that TypeScript turns it to that actually runs inside your browser. So now if we right click and we say open or reveal in Explorer, this is going to pull up the root directory to where this HTML page lives. And you can see my browser, or not my browser, but my operating system knows that this is a web page. So it's by default using Chrome. So if I double click on it, you can see that we get the on the fly message that is our variable. And we're getting that alerted to the screen. All right, so now we're ready to actually go ahead and start writing HTML, or not really HTML, but JavaScript. Geez, I can't talk. All right, we're going to be writing React that is going to be writing our actual JavaScript to the screen. So in order to do that, we want to go ahead and change this stuff inside the index.ts file. And we actually want to right click on this index.ts file, and we're going to rename it to TSX. And you can see that the React symbol actually shows up when we say TSX. And the reason why is our TSX files signify any time that we're going to be using React in that file. We need to have it as a TSX file. And the reason for that is because React uses something called JSX, and it's a long story there, but basically JSX is very HTML-like, but it's not quite HTML, and it makes it easier to write our React components and our React code. But TypeScript needs to know the difference between just regular TypeScript and TypeScript that includes React stuff, and it's because of that JSX. Now that we've changed it, we want to go ahead and import the library. So we're going to import all, which is the star symbol, which means import all, and we're going to say as React from, and then we're going to say from React. So we're importing the React library, and because we also need to render React HTML to the screen, we need to also do the same thing and say React DOM from the React DOM project that we loaded earlier. All right, and now we've imported both of those. So in order for us to actually write some HTML to the screen using React, we're going to say React DOM, and then we're going to call the render function that's on top of that. And here, this is JSX. So it looks like HTML, but it's not quite. The second argument that we need to pass to this render function, though, we need to put a comma here, and we need to say document dot query selector, and then here we're going to give it the value of root, and that's going to be the element that we're going to say, hey, attach this HTML to the root element. So in order to do that, we need to go ahead and create that root element in our HTML page right now. So we're going to say div id equals root, and this is going to be where React is just injected right onto the page at this tag inside of our HTML. So once this loads, it's going to say, hey, find the root tag, inject this HTML that is a header tag that says this is JSX. So if we press Control S and save it, you're going to notice that our JavaScript now has a bunch of extra stuff in here, and this is that automatic compilation that's going on. So if we pull this back up in a browser, and I'm going to close this and refresh the page, and we're going to have a problem here. So let's go ahead and take a look. And it says exports is not defined. Now, this is where we end up coming into another dependency within our project. And this is something that a lot of people, they're like, well, why do I need Webpack? And this is why Webpack is always used in modern day projects, because by default, when our code got compiled, you can see here that we're using this exports right here. So exports, it doesn't know how to handle this, and only Webpack really knows how to handle this sort of exporting. So what we need to do is we're going to install Webpack into our project so that Webpack handles the loading of the necessary components that you need, which is like React and React DOM. And then also any other components that you create for your project. If you want to import them the way that we did with React and React DOM, you need to use Webpack in order to do that. So that way, between the combination of TypeScript and Webpack and React, it's going to jam all of your code and everything you need into one single JavaScript file, but all the importing is going to work without you having to rely upon the browser in order to do that. So now that Webpack has played into the equation, if you have Visual Studio Code open, make sure you click on this, make sure your terminal is open, but if you click on the plus sign, you can open up a new terminal window. And now you can use the drop down to actually jump between all the different, like here's where our Webpack is watching, and here's another empty terminal, and we can go back to npm install, and we're going to say, this is going to be a developer dependency as well, so we'll say -d for developer dependency. And we're going to say we want to install Webpack and also Webpack CLI. All right, so if you guys are on a crappy Windows machine, you might end up getting some sort of operation not permitted, that there's a problem here. What you need to do is actually run VS Code in administrator mode. So if you go and right click and say run as administrator, these errors seem to pop up at any given moment. It seems like it's kind of development for you, but basically what this is saying is that it doesn't have permission to write the file. It's kind of like using a sudo command if you're on Linux or Mac. So again, I'll say npm install -d for development dependency and Webpack, and then Webpack CLI. And now that that went through, everything is fine because we have administrative permission to write the files that we need. And because we're using Webpack, we now need to go ahead and create, just like we did with our TypeScript configuration file, we're going to create a Webpack configuration file to say how Webpack should work. So this is going to be called webpack.config.js. And I know it's a weird name, but you have to actually spell it out that way. Otherwise, Webpack is not going to know how to find the configuration files and understand how to interact. Webpack does all kinds of stuff for us, not just loading modules, but it also does things like if you want to make your JavaScript files smaller, and if you want to like change, like do something that's like called minifying, which takes all the white space out of your JavaScript, you can do all that stuff with Webpack. You can also load images. You can write Sass and convert that to CSS and have it all done on one build command. Right now, that's way too much for what we're trying to do, but we do need to go ahead and define this webpack config.js so that Webpack knows that, okay, we're going to be compiling some TypeScript and React files. All right, so one of the first things that we want to do is we're going to go ahead and create a path, and we're going to require the path module, which is a module that is included with our Node.js installation, and that just allows us to actually say, okay, what directory is this project located in? And we'll use that in just a second, but we're defining the path variable and saying that we need to require that library from Node.js. Next, we're going to do the module.exports, and this is going to be equal to a JavaScript object, and this is also a built-in Node thing, so Webpack uses Node.js. But here what we can do is we can give a bunch of different commands. Like here's our entry command, and it's going to say, where is this starting file located? And we're going to say that it's our index.tsx is our starting file. Now we're going to go ahead and define our output. So the output is what it's going to be. What is the overall the JavaScript file, the big bundled file that we're going to create, because our entire application with React is going to be just one JavaScript file. So the output is going to be equal to an object, and we need to do a couple of key value pairs here. So one is the file name, and this, we'll just call it our bundle.js. That's going to be the file name that we want to include. And really, if we don't, we'll do it there. And now what we want to do is say, give it a path. So what directory do we want to put this file into? And this is where we're going to say path.resolve. And this is where we're using the constant that we just defined up here. If you do two underscores and then say dir name, which stands for directory name, this will then find the directory from where the Webpack config is actually located on your computer. So it can be under any file, but that dir name is going to find that file, the root directory to where this Webpack config is. And then we just want to say, you know what, I want to put it in a dist folder, which will be created for us automatically, which stands for distribution, and it will put it inside of there, and it's going to call the file bundle.js. All right, guys, so now that we've installed Webpack, what we want to do is go back over to our package.json file, and under the build command that we had defined before, we now want to say, you know what, we want Webpack to actually be the one who compiles this project and not just TypeScript. Since TypeScript doesn't know how to import stuff like React and React DOM, Webpack will be able to do that, and this tells it to use Webpack. So the thing is, though, is if we go to run this, we will go ahead and we will have an error message, and I just want to show you guys so you guys can see all these error messages. I didn't mean to run Webpack. I meant to run build. So I'm going to say npm run build, and I'm going to show you the error message that occurs so you guys can see everything that's going on. And here you can see module parse failed, unexpected token, may need an appropriate loader. So because we are loading files with TypeScript, there is a project, and it's another dependency that we're going to need for development with TypeScript and React, and that is called the TS loader. So we need to go ahead and install that now. So we're going to say npm install -d for developer dependency, and then say TS loader. And this is a separate project, and this will allow us to actually load TypeScript files as needed. All right, so now if we run, we can say npm run build. It's going to automatically use the loader, but we're still going to get another message that says, hey, we don't know how to handle this file type. And it's because we did not configure Webpack to actually look for TSX files and say, hey, when you run into a TSX file, I want you to use the TS loader. So we have to be very explicit, meaning we have to spell it all out for Webpack in order for all this to work. And that's what we're going to do right now. So under something called the module, we're going to go ahead and define a object. So this is just a JavaScript object, and we're going to have a key value called rules. And this is a list. So this is going to be a JavaScript list. And inside of here, it's going to take in a bunch of different objects, or it could. We only need to define one object. And we're going to say test. And this is going to be a regular expression to say, hey, anytime you run into a TSX file type, and really we want it to say ending in a TSX file type, we wanted to say use, so define the TS loader, which is what we just installed. So we're going to say anytime you run into a TSX, use that TS loader project that we just installed. And then by default, we don't want this to be looking in our node modules folder. So we're going to go ahead and define that. So we're going to say, don't worry about anything that's inside of our node modules folder. Whenever we install something using npm, it all goes inside this node modules. And these are all the different packages that are needed for the projects that we've installed. Everything from TS, like TypeScript, to the TypeScript loader, Webpack, all that stuff is going inside your local node modules folder. All right, and then we need to add one more option to this Webpack configuration. And we want it to say, hey, anytime you run into a TSX extension, we want Webpack to handle that. So that way it'll use the TypeScript loader that we've created. So we need to go ahead and give it an extensions argument, which is just a bunch of different files. So it says listen for any TS files or .tsx files. And we could even tell Webpack to listen to any sort of .js files as well if we want to go ahead and have it compile JavaScript for us too. Like, that's a longer story, but if you were going to use Babel, you can use both Babel and JavaScript and TypeScript in the same project. But you need to tell Webpack, hey, I need you to handle these different file extensions that you might run across. So from this point on, we're now using Webpack to compile all of our TypeScript code. So this stuff is going to be on GitHub if you guys don't want to have to manually type all that out. I'm hoping that by going through these error messages, these things that you're going to run into on your own, because you can watch some pie in the sky tutorial, but as soon as you try to deviate, you're going to run into these problems. You're not going to have any idea on how to resolve them. And that's why it's best to just go through, hold your hand. I know it's taken a long time to even get to the point where we can even write React code, but this is going to be what every core TypeScript and React project is consisting of. And then even if you didn't want to go the TypeScript direction, you're still going to run into this with most modern React projects using something called Babel instead of TypeScript. So to learn how all this stuff works, I think is really invaluable, and that's why we're doing it. So now let's go ahead and do the run build command again. All right, so now that everything has finally gone well for us, we finally got our distribution folder, we got our bundle.js file, and now it includes all this code. Look at all this code. All this code is needed in order to load React, React DOM, to execute our TypeScript, to convert the JSX to JavaScript. All this stuff is now going on. I've showed you how to do it all, like hand by hand, line by line, hand by hand. I'm not sure what the hell that means, but line by line, you guys now know how to get to where you're at. Now, you might notice here that it just compiled and it's no longer watching for us because it's not using the tsconfig anymore. It's now using Webpack and for everything. So we can add one extra argument on here to say watch, just like we did before. And we're going to say true. Every key value pair, make sure you have a comma, otherwise it will mess up. But now that we do that, if we run the build command again, we don't have to keep running it over and over again. It's going to continually build, and you can see that it's watching, it's still running. And if we were to change something in our source here, if we were to, and we can even delete this JS file now, we're not going to use it. Now, if I were to say this is your dog's jank or something, you know, now this is going to recompile, and you can see it actually did it. It created it for us. And let's go ahead and open up the HTML page and see if we can actually get some HTML rendered to our browser. All right, so I have the file open like we did before. I'm going to refresh, and then, oh, and that's another thing too. Look, see, I'm including all the error messages. It's saying it's still looking for the index.js file in our HTML. So let's go back into our HTML and say, hey, we don't want you to look for the index.js anymore. We want you to find the bundle file that's in our distribution folder. So if we go back to our index.html, you can see it's looking for an index.js file that's no longer there. So instead of this source, we're going to say, you know what, I want you to look inside the dist folder and look and then grab the bundle file that we have Webpack build for us, which is right in here. And this is, again, we're not going to have to configure too much more from here, but now you guys have seen all the different angles and stuff. So by updating that, we should now get finally working code. So back to the browser, refresh, and then finally React is now rendering this information. So if we right click, you're going to see that this HTML that got put inside of here is inside the root tag that we told React to bind to. And all our React, but this is our main component. So at the beginning of the tutorial, I said you have your overall, Christmas present, Hanukkah present, whatever you got, and then everything inside of there are a bunch of different components. So if we go back to the index.tsx, there always has to be one main component, and it could just be a simple div tag. Like right here is just a simple div tag, and it can include all kinds of HTML in here. So like H1 testing, we could put a paragraph tag in here. This is a paragraph. And we could even put anchors in here. So right now we're not going to click on anything, but click me. So it's not going to point to anything. But these are all these different HTML elements that sit inside here, but this is the Christmas present box, and it contains everything. So all these are child components or elements inside of the overall main tag, which is a div tag. So there's always got to be some sort of surrounding, either a div tag. In most cases, it's going to be a div, but it doesn't have to be. But that overall present is your React application, and it just consists of a bunch of other smaller presents, which are your components inside of it. And that's how you need to view your overall React architecture when you're developing these React applications. So press Control S to save, go back and let's look at this stuff in the browser. And if I refresh, you can see that we have these different elements. We have an H1, we have a paragraph tag, and we have an anchor tag. All right, guys, so now that we've gotten this far, let's go ahead and make our first actual custom React component. And one thing I want you guys to keep in mind here is the way that we create this component is the way that all React architecture is built. So I worked for a company one time, they're called CoStar, and they make things like apartments.com and LoopNet, and CoStar is actually a humongous commercial real estate analytics company. And they were actually, when I got hired onto that team, I was working to rewrite the LoopNet application from an older legacy code base into a modern React code base. And at the time, I had some previous React experience with my previous employer, and I had also done some React at home, and I had videos going back a long time. So I had actually felt like I had a pretty good grasp of React. But when I went there, I realized that, holy crap, this application's huge. So as we were developing it, it was and when I say humongous, there was like thousands of components. And those components had a lot of functionality on each one of them. And everything from a radio button to an input for like text input, for just even like headers and paragraph text and all kinds of stuff, they were all their own separate component. And the reason why is because you get to use those components over and over again and really identify and create what is considered to be an API on that controller. So you can essentially say, you know what, you guys want to write a new web page, you're going to follow our design standards by using our custom components, and then you're going to go ahead and apply, you want to change the color of the text, or you want to do this or that. You can do all that by passing in data to the components, and we'll see how to do that in a moment. But the key point I'm trying to make here is that the reason why this is good architecture is because you get to reuse that code, and you can also be very explicit and make sure that people are using the code base in the right way, because you design the components to only work in one particular way. although they can work in as many ways as you want, but a company typically wants to keep the same look and feel across all their pages. So as new pages of functionality get created, then as long as everybody's following the component architecture correctly, they're calling the right APIs and methods and passing the right data to the component, then it's going to behave in a predictable way. So we're going to see how to do that now. Let's go ahead and create our first component. And since we have a header here that's called testing, we're going to create a component that we're just going to call our header.tsx file. All right, and for every component that you make, you have to import React. So you're going to say import all as React from React. Now this time though, you don't have to import the React DOM. Only your outer present, your outer component, the Christmas present reference I was making before, that is the only one that's going to use React DOM.render. You only have to use React DOM to render your HTML, and you typically only do it one time for your application, and that is like your root starting point. If you've ever done like Java development or C# development, that is your main function. It's the starting point. It's really, it's the only time you're going to use React DOM really. So let's go ahead and after we've imported React, let's go ahead and use it. Now we're going to look at the more modern architecture of React. I'm not going to waste your time with the class-based React components. And the reason why is React has now gone into a functional component style. So most of your modern React, and especially if you're looking to get hired, all the new code bases are going to be using it the way that we're going to be developing it in this tutorial series. So to do that, we're just simply declaring a function, because React is just JavaScript function calls that spit out HTML. But under the covers, there's quite a bit going on there. But let's go ahead and just say whatever the component name is going to be called, that's what you want it to be. Now with React components, it is important that you have to know that it is Pascal casing, so it has to be capitalized. Every word of your component name should be capitalized. And that is, yeah, it's just a rule. So just follow that rule and shut up. I'm just kidding. No, so let's go ahead and spit out our H1 component. So we're going to say hello world. And let's do a exclamation mark. It's more legit that way. All right, so now we have this this function header component. All right, and we're just going to keep it here. So it's just going to be this static HTML message. And you're probably like, well, why the hell would I make a component that has text in it? And we're going to see in just a moment. You can change this to be very dynamic, and we'll look at that in a moment. But for right now, let's go ahead and remove this header tag, because we're going to use our custom component instead. But in order to do that, we need to go ahead and import it. So we're going to import the name of our component, which we called header. But then we have to say, where are we importing it from? So we have to tell it, import it from the header file. All right, now this is going to complain and say that you're not, you brought it in, but it's not being used. And then another thing too is when you run into a situation like this where it says that there is no export, it's because the component itself needs to be exported. So you want to say export and then the name of the component. And then our message should go away when this thing is, there it goes. No, it's still there. All right, anyway, it's because it's not saving yet. Okay, let's go ahead and use this now. So we're going to use our header component. Now keep in mind with JSX, you could have a opening header tag and a closing header tag, or actually, you know what? I made a mistake here. I'm sorry. If you wanted to, all right, this is a good thing. I actually keep all my errors in here, and this is just stuff that you're going to run into as you're coding, honestly, and it's stuff that I know all about. I'm just doing it wrong. But if you want to actually have multiple exports per file, you have to actually wrap it inside these curly braces here, and that's one way of doing it. But if I didn't want to do that, and if I just wanted to say import header, just like the way that we had it, then you have to export a default. So you have to say from our header file, export default, and then the name of the component. And if I did that, then it's not going to complain, and you can see that it compiles. So that is the difference between the two. If you want to import something without it being in curly braces, then you have to actually say there has to be a default export for the file. If there is no default export, you have to wrap it like this. and it's going to give you the error message, and then you would just go like this and put it inside the curly braces. So again, it's good to actually include all these error messages in the tutorial. I don't have this stuff planned out. It's not a pie in the sky thing. Coding is never that way. You're going to be writing code and shit's going to break all the time. And that's just the way it is. And like, there's all these tutorials out there, or even the books that gives you these, these perfect pie in the sky scenarios. And if you don't run into error messages, the only way you really learn is by breaking stuff. So anyway, let's go back to how you use the custom component. Now, you can just close it off with this bracket here. That's the shorthand way. So that's the way most code is done when you see stuff in a React code base. But you can also be very explicit. But you can see this is just kind of unnecessary text, so you don't really need to do that. So let's not do that. And we're just going to close it off the shorthand way. All right, so now by doing that, if we go back to our web page, and we refresh it, and you can see that we have the hello world. So now we're using an actual custom React component that we created ourselves. But the problem with this approach right now is that hello world is static. It means that it does, it doesn't change. It's just there. It's like a brick wall. It doesn't ever change unless it crumbles and falls apart. But we don't deal with that in coding. Although code bases can crumble and fall apart for sure. But anyway, you guys get my point. Static means it doesn't change. But how do we actually say, you know what, I want this header component to be more dynamic? And the way you do that is through something called props. And props are the way to pass data to your component from the parent. And the data that you pass within props, it is going to be considered static data, meaning that the data should not change when you're going to use props. Now, we're going to see in a moment, though, if there's some sort of dynamic value that says, based on the time of day, this value is going to change this, that, and the other thing. Or you click a button somewhere and all of a sudden that's supposed to change based on a button click that happens somewhere else on the page. We're going to see how to do like truly dynamic behavior with state. But for right now, when you're dealing with data that you're passing to your component, if it's relatively simple data like here, what we would want to do is pass in text that is displayed inside the header. And that is the perfect example of something where you would want to use a prop versus state. So state, we'll see in a moment examples, but that's going to be data that changes all the time. But the concepts are the same as far as how you pass the data to your component. So how do we pass data to the component via props? Well, you have to actually pass in props to your function. So just like that, we're going to pass in some props. And then the props can have all kinds of different values, from strings to numbers to like lists, arrays, all kinds of stuff. But we're just going to pass in some simple text for right now. But to be able to use that, we need to reference the props inside curly braces inside of our JSX HTML. So in here, we're going to say props and then whatever it is that we're looking for. In this case, we're going to call this text. But the problem is at the moment is we're not passing any text to our component. So if I were to refresh the page, you're going to get nothing for the header. The header is going to be there, but it's going to be empty. So you can see it's empty. There's no text in there. We didn't pass any text as a prop. So in order to pass the prop, you need to actually use HTML attributes, which are things like on an anchor tag for hyperlinks. There's an href, which says which web page should I go to. Those are called attributes on your HTML, and JSX/HTML that we're looking at right now also has attributes, and that's how we're going to do it. So we're going to create an attribute called text, and then just say your dogs, Jank. I used to say your mom, man, but like people get offended by that. Like, I don't know why people get offended so easily. So anyway, if I refresh now, you can see that we get your dogs and Jank now passed in there. So now we have a lot of control and we have a lot of dynamic behavior. We have one shared component and I can actually use it as many times as I want. And you know what? I don't care if people get offended. Boom, look at that. And you can see here the same component can be used over and over again. So you could use it 1,000,000 times if you wanted to. But another key feature of this is, what if you were like, you know what, I want to put some inline style in here. If you want to do style tags in JSX, it's kind of weird. You have to pass in an actual object of key value pairs. But something like, if I wanted to have the color always be red, then I could just define that right into the component and be like, anybody who uses my header tag, it's always going to be red. And now if I refresh, you get red. And, you know, that's probably not the best way to do it. And typically what you're going to see is that you're going to have classes from CSS actually applied. And, you know, it'll be like a class name here. But we'll get into that in just a moment. In fact, you know what? Let's do it now. Let's do this now. All right, we're going to go ahead and I want to create a folder that we're going to call our public folder. Public. One second. So public folder, I'm just kidding. And in here, we're going to create a CSS file. So we'll just call this a main.css, which is your cascading style sheets. And here, this would be a better way to do it. We'll just say primary header is the name of our class. And we're going to say that the color is red. All right, so now that we've done that, we need to go ahead and reference our CSS in our HTML so it can load. And you're going to say style sheet. href, and we're going to point to the public main.css. All right, we'll close that off. So now we're loading the CSS, and a better way and a more common way that you're going to see with these components is that they're going to reference an actual class name instead of this style. Now, the funny thing about attributes inside of JSX is that they are camel case, meaning that like something like anything that has, so it's weird, like there is no class in JSX. It is class name, and that is like one of these weird quirks that like normally under an HTML element it's going to be class equals blah blah blah, but you can see it's going to throw an error message and it says, you know, blah blah blah. What does this even say? Is not assignable, blah, class does not exist on type. Anyway, you quickly become accustomed to the fact that it's class name. And here we can go ahead and say primary header and save it. And then we're going to get the same result. And just so that we can see, I'm going to go ahead and change the font size of this to like 100 pixels, make it huge. And now when we refresh, you're going to see it's a really big header. Clearly way too big. But it's more reusable in this way because you want your CSS to be controlling your styles. We'd probably want it somewhere around there. I don't want to save that actually. But inside of here, we can actually also use Chrome to help us debug stuff, which is another reason why it's just easier to do this with external classes. We can find a color that we like. Hey, you know, I like that color. We're going to keep that. Boom. Copy that. Pull up this. Change the color. And put this back at 24 pixels. And now a primary header can be used wherever you want. And it's just a cleaner approach instead of having the style. But again, you saw that if you wanted to put inline style on this, you have to actually use a JavaScript object within the curly braces, which is somewhat weird. But again, going back to the camel case thing with React, it's something you have to get used to because here, let's say something like font size, right? Something that has a hyphen in it. Normally the CSS is this, but this doesn't make sense in JavaScript, which is really what JSX is. So you have to instead use camel case. You're going to say, you would do it like that. You would do, I'm sorry, this has to be in just like a JavaScript object. You have to have that inside a string value. So key value, string value, and then anything that has a hyphen for your attribute, it needs to be camel cased, which I know is kind of weird, but you get used to it. And again, now we have this combination, so it went back to being big because we put the style in line. And you can see if we look inside here that it turns it to this camel, to the hyphenated real version of the style versus the camel case JSX version. And again, you'll just eventually get used to that the more you do it. So it's really important to touch upon all these things because you can't be a React expert without it. All right, guys, so we've seen how to pass some text to our component. Now, because this is TypeScript, one of the biggest benefits of TypeScript and to enforce to make sure people don't do crazy stuff with your component, you can force types on this. So you can actually define like an actual type. So if I wanted to do that, I can actually say, you know what, I want props to be, in this case, we have text, right? So we know that text is going to be a string. Maybe we don't want it to be a number. Right now, we could actually pass in a number if we wanted to. And maybe we don't want that. Maybe we want to restrict it to say, hey, anybody that's using a header, we only want you to use a string. So if I wanted to enforce that rule, what I'm going to do is I'm going to declare a type, which we're going to call our, and this is just by convention. And you're always going to say whatever your component name is and then have props on the end. And this is going to equal essentially an object, but it's going to be an object that has key value pairs to say what it is that's going to be passed in. So in this case, there's a text, and then we want the value to be a string. And then we want it to say down here to say, hey, to make sure that they only pass in the right type of prop, we're going to say that it's of type header props. So this actually now will restrict other crazy stuff from being injected in, and also if they don't inject the right amount of data, it will complain. So for instance, if I now try to say, let's pass nothing in, you can see that instead of this even compiling, it immediately complains and says, hey, your text is missing and it's required. Now, if for some reason you wanted that value to be optional, then you just have to put a question mark here, which means that it could be null. And that means you allow null values. But in this case, we don't want to allow a null value for the text field because in the header, it doesn't need to be there. If it's just an empty H1, that would just be crappy HTML. So you can see that gives you the type protection. That's one of the main reasons for TypeScript and its use within React, especially when you start getting into really large and complicated projects. Every component is going to have all kinds of data that it needs in order to function properly. And this type of type checking make sure that you don't have runtime errors as the application's being used later on down the road. So again, to satisfy this, we can just pass in a text value for the prop, and now it's satisfied. It compiles again, and everything's fine. Now, another thing you should never do with a component is you should never change your props inside the component. For instance, you could actually say, you know what, props.text equals don't do this. This is considered an unpure function. Although it'll allow you, it's something you should never do because you just never do that. You know what I mean? Like if your value does need to be dynamic, we're going to see in a moment that we're not going to use, we're not going to do it this way. We're actually going to hold the value in state and allow the state to manipulate the value. We want pure functions within React. We want to know when you talk about pure functions, you want a component to behave the same way all the time, no matter what. So again, although your component allows you to do that, that actually goes against functional programming principles and pure functions with like the way that we're doing this with props. If you had a value that's dynamic, then we're going to want to use state for that value. And we're going to get into state in a moment. All right, I'm going to go ahead and delete the improper use of our function here. All right, so this is a good header component. This is good. We can call that one a day. So let's go ahead and create a new component, which we're just going to call it our date.tsx. So this is going to be a component that actually gets the date. So again, like we've seen before, import all as React from React. All right, so we'll just call this date. And here for right now, we're just going to return, for right now, we're going to have it be, we're just going to have a button here that we're going to click. So we're going to just not do anything with it. We're just going to say get the date. So for this component, because we're actually dealing with the date, and JavaScript has a built-in date object. It's like a date type. It gets things like, it gets all kinds of crap related to times and dates. And this is actually a terrible name for it because we don't want to overwrite any of that date functionality. So you should never actually define methods, components, or even variable names that share the same thing with JavaScript's relatively minimal library. So things like the math object or the date object, you don't want to overwrite that. So really we want probably this to be called something like custom date, and we're going to call it that. And I'll just change this as well. Now, a lot of people in React development, they're using something called kebab casing. So we've talked about Pascal casing and camel casing. This is kebab casing, where all every word is separated by a hyphen that looks like it's all on like a shish kebab. Like you got your steak right here and your onion right here. That's called kebab casing. So yeah, just that's what a lot of people do with their component name. But whatever sort of convention you decide to use, just make sure you stick with it. And let's go ahead and make sure we export this. So we're going to say export our custom date. And the reason why we don't want to overwrite that date is I'm actually going to have a date variable. So we're going to call this let date equals new date. And this is where you would end up getting an error message. Like if we name this thing date, then you're going to get an error message here because it says only, it can't be called on the, anyway, it's trying to new up your own function that you're creating. So that's why we ended up doing custom date to solve that. And then date itself is, you could see, enables basic storage and retrieval of dates and times. That's a built-in JavaScript thing. All right, so now that we actually have our own private variable that is on our function component, we can reference that variable just like this inside curly braces like we saw with our props. So it's just going to reference this name. And let's go ahead and see that in action. And honestly, I don't know why the mouse cursor was glitching out like that. That's completely crazy, but I guess that's Windows for you probably, or something. But before we can actually see this in action, we need to go ahead and use our custom component inside of our main starting point. So let's go ahead and import the custom date component. And we're going to put it under the header. All right, so now we'll be able to go back and see this. And yeah, this is something else I want to show you guys. All right, so check this out. When you get a message like this, it's going to say minified React error message. And what this is that it does not actually display what the problem is. So you have to actually go into your console and click on the link, and it'll actually tell you what the problem is here. So it says error decoder, objects are not valid as React children. And there's going to be all kinds of different error messages that React will spit out, but it's all minified now to kind of cut down on the overall file size of the React project. So instead, the console will just direct you to a URL that actually explains what the error message is. And the reason for the error message is because we are newing up a date object, and then we're trying to reference an actual object here. And it says, hey, date is a child of this React component that is a div, that is like the, the outer container of this particular component. And it can't have a child element inside of it that is an object. And the reason why is we just need a string value from this. So really, if we're using proper TypeScript, we should actually specify, hey, date is a string value. And you would get that error message before it even compiles, because you'll see date is not assignable to type string, because date is going to return an object, and date is saying, hey, I want this variable to be a string. So this could actually be, it would warn the developer as they're doing it, okay, clearly I need to call like toDate string, and that is a method. So I'll call it as a method here, and then everything is fine. It compiles fine. But that is actually considered a runtime error. And we didn't get the error during our compilation, and that is the exact reason why people use TypeScript. One of the biggest problems with JavaScript development is type safety, and really it's about any language like Perl, PHP, these things that magically change data types. Those types of languages can be really dangerous when it comes to runtime errors. It's very difficult to catch all those things. So in languages like JavaScript, you have like use strict mode, Perl has a use strict mode, probably PHP too. I don't know. But JavaScript's always been plagued with that problem, and that is really the reason for TypeScript, because so much code has to be written in JavaScript to prevent those types of errors from actually occurring, all kinds of type coercions and all kinds of stuff. So anyway, let's go ahead and take a look at this. We have our date time, which is being printed out as a string, and then we have this button. It doesn't do anything when we click it, and we're going to see how to get this a little bit more dynamic. So in order to get this a little bit more dynamic, let's go ahead and say, you know what? This date is a string, and we're going to say it just equals an empty string. All right, and we're going to reference it here. So I would show you the page where you guys can look at it if you want, but obviously you're not going to get anything for the date. It's just going to be an empty thing. It's just going to show the button. Hell, why don't I show it? So you can see there is no date here. I'm going to close this out. So there's nothing here. So now what I want to do is I want to actually wire up a click event. So when you click on that button, it's going to display the date. So the way we should do that is anytime you have dynamic functionality like click events and such on your components, then we can go ahead and make them more dynamic by actually attaching functions onto our React function component. And you can, it's just like any other, it's just like any other function in JavaScript / TypeScript. Here is the shorthand version of our function. So we're saying date is attached to our custom date component. And then we have a getDate method attached to that component. And now we can actually say, you know what, when you call that, we want to go ahead and change the value of our local variable called date. And we're going to say new date dot to date string, like we saw before. And then now we need to actually say, you know what, when you click the button, I want you to call this function. You can see it's grayed out. And this is one of the reasons why Visual Studio Code is very helpful. Any sort of editor is helpful, but I love Visual Studio Code actually. But this is telling you right here, getDate is declared, but its value is never read. It means that it's not being used. So why did you declare it if nobody's ever going to use it? It's just unnecessary text. So let's go ahead and use that now. So if you want to do an onClick event with your component, you need to pass in the function name, which is getDate, into the curly brace here. So we're going to say getDate. Save it, and now when we click on the button, our date should appear where we want it to appear. So to see this in action, let's go ahead and take a look. We're going to press get date, and we get nothing. And the reason why this is because props are immutable, and they should not change the value. So this is a pure function component. So if you wanted it to be dynamic, then it should be passed in as a prop, the way that we saw it with the text value. You could pass in a date to it, and the parent could say, every time I pass something to it, it's going to re-render its, the component, and you could get the dynamic behavior that way. But if you truly want a value from within your component to update itself, then that is when you need to actually use state. And that's what we're going to transition to right now, so we can take a look at that. And also, I just want to make sure you guys are aware of the fact that the function is being called. So if I were to just do a simple alert hello world message on the button click, you'll see that the button click is actually occurring. So if I refresh and I hit the button click, you can see that, okay, we're getting the JavaScript is firing, but the prop, even though we're updating the prop, React does not know to re-render itself because you didn't tell it to say, hey, this date is something that I want you to keep track of, and every time it changes, I want you to re-render yourself. So in order for that to happen, that's where we're going to use state. And we're actually going to use a modern version of how to do state maintenance within React via something called React hooks. All right, guys, so to see React hooks in action, what we need to do is we need to go ahead and rethink the way that all this is done. In a way. So because we saw before that we had this date prop, and it's really not a prop because it's not being passed in as a prop, but we have this date value, but React is not listening to any changes to that value. So when we click the button, even though we changed the value, it was not reflected in the component. So in order for that to happen, we need to add it to something called state. And state keeps track of any sort of values that change and then re-render all the time. And to do that, let's get rid of this alert message. And what we need to do is we're going to declare, number one, the value that like the variable name that we want it to keep track of, which could be whatever variable name you want. And then we also need to declare a function that is going to be responsible for changing that variable name or variable's value. I'm sorry. So to see that, we're going to say, we can just use the constant function. You could use a let as well. It doesn't really matter, but you could say let if you just want to go with that convention. So a lot of people can, you could use constants or dates. It doesn't matter, but a constant would probably be better. But right now, pretty much all this stuff is being turned to vars anyway, so it doesn't have much of a performance detriment or even benefit to do it with a const. So in case you guys are wondering what a constant is, obviously it's that. It's just a constant that doesn't ever change. But anyway, so we're going to say, you know what, since the name of our variable is date, we can leave it at that. Now you're going to get the error message saying, hey, you've already declared it, so you can't declare it twice, and that's fine. But now let's go ahead and say, you know what, we want the function that we're going to say, hey, when the date changes, we want it to be called setDate. So we're going to say that this equals react.use state. And this is something, it's using something called React hooks. And to get rid of this error message, let's go ahead and get rid of this this value. And because we had date as an empty string before I deleted that, you could see that it was just an empty string. Then what I could do is I can actually say, if I want date to have a default value of an empty string, I can just pass in the empty string. This empty string will be assigned to this date variable. And then if I want to update the date variable, I need to call this second argument, which is setDate. And that is going to be the function that's actually going to update the date. So our onClick is calling getDate, which is right here, which is a function. And what we need to do here is, instead of saying date equals, we're going to actually say setDate. So we're going to call our setDate, and we're going to call it as a function and pass in this argument to the function. So we're now calling setDate from within getDate. And you'll see now that we can actually dynamically change this value after the button is clicked. So it's going to be empty by default because that's where we defined it, that's what we set it to when we defined it. And then we said, hey, when this function is executed, which it gets executed on a button click, then you're going to call this setDate function, which is here, to change the value of date to this value here, and this will update itself to show the new value. So here's the example, the button, there's no date here. You click get date, and now you have the date. And we could even get this more dynamic. Like if we were to say, you know what, get time, then, you know, let's do that now, you know, let's do that now. So even though we call this, we could even change this to time. Let's just do this all like set time. And we could say set time, or no, we'll just say get time, because that does need to be different. And then we're going to call this time. This is going to be called get time. And instead of this being, so we're going to let's see, get two-time string. All right, there we go. So it's the same thing, and now we're gonna change this to say get time. And really, we'd want to change the friggin' custom date to custom time, but who the hell cares at this point? All right, I just want to show you something more dynamic though. So every time you click it, we'll get a new time. So if we go back and we click on get time, you can see that we get the amount of seconds that are currently going on. So every time I click it, we're now at 10 seconds, 12 seconds, 13, 14, 15, 16. 17, 18. So as I'm clicking it, it's getting the time. And that's pretty cool, right? So now that's a much more dynamic value. All right, guys, so we're making some progress here. Let's make a new component that we're going to call our Fruit Loops component. And yes, like the cereal. And the reason why is I want to show you how to actually do lists, because a lot of people are like, how the hell do you do lists? Because it's not exactly straightforward within JSX. There's a specific way that we have to do it. So just like we have been import all from React. Oh wait, I'm sorry. As a React from React. And we're going to go ahead and say function Fruit Loops. Yeah, we'll say loops. That's fine. And then here we're going to, I'm not sure why I said render. Render is the old class-based system, but here we're going to go ahead and we're going to have a UL element. And for every item in a list, and we're just going to say that the list of values, we're going to define it right here. So let fruit equal, and it's just a list of values. So red, green, blue, yellow. Okay. So this is just a simple array of values. And if I wanted to do it the TypeScript way, you'd obviously say that it's an array of string values. And I hate how it does that right here, but oh, that's funny. Look at this error message here. Types can only be used in a TS file. I'm actually still used to the JavaScript way as well. So like we can name stuff JSX in the JavaScript way, but it needs to be TSX, and you can see that we can now have the declared types. So we're saying it's an array of string values. Each one of these are a string. And I had that wrong file extension name there. So if we want to loop over all the values, then what we can do is reference our map, the map function, which is we could, since this is an array, it's iterable. So it means you can iterate, meaning just 1, 2, 3, 4 go over in a loop, just like a for loop, fruit loop. Yep. So to do that, what we're going to do inside the curly braces, we're going to say whatever the variable name is, which is our array, and then we're going to say map. And then map is a function, and you could end up, you could get the value, which is the string value, and then also the index. And here, make sure you close it off with the curly brace and then the end of the function argument here. And inside of this element, what we want to do is actually say return an li element. And anytime you're dealing with an iterable, meaning that React is going through a loop of something and it's creating an element for each item in the array, then React needs to have something special on it, which is called the key, and it has to be a unique value. So the easiest way to provide a unique value is to provide the index number for whatever index value is for, like, you know, for the array. So computers start counting at 0. So the first item will be 0. The next one will be 1. And that is going to be your index value. So you're going to assign that to your key. So that way, every item that's spit out, and it's going to be however many items are in our array, they're all going to have that unique value for their key value. And now inside the li, we're just simply going to say, let's reference the value. So that's how you actually loop over stuff in React. In this case, it's just simply a string, but you could be looping over objects. And if you were looping over an object, instead of it being value, you'd be referencing the object, and you'd say like value.title or whatever it is. But in this case, it's not an object. It's just simply a string. So this is going to be the string value. So let's go ahead and export this function. All right, and then inside of our index, we're going to go ahead and import that. All right, and then to see that in action, we can just simply reference the new component. And now let's see if our fruit loops get rendered. And there they are. They're all inside a bunch. It's an unordered list. So these are all li elements. Now let's also add another feature here. This is going to be conditional logic. And we can actually put conditional logic right inside of this, this loop here to say, let's go ahead and just detect what value we're dealing with. And we can assign a dynamic color. And this isn't like the best way to go about it, but it's a good example of how you can do conditional logic from within your JSX, your functionality, because this is really all just regular JavaScript / TypeScript inside of these curly braces. So if I wanted to do something like, you know, if value equals red, then I can go ahead and say, and outside of the if statement, I'll go ahead and just even define a variable and say let color equal an empty string. And if we want to do proper TypeScript, we're going to say that this color variable is a string type. So that way we can't declare anything else to it. And here I could say, so if value equals red, I could say color equals red. Now, because all these are actually, we'll see that in just a moment. But here's an example. So if I were to say, you know what, let's add a style. And like we said, like I've showed you before, if you want to do inline styling, you got to pass in an actual JavaScript object. And I could say, you know what, color equals the color. So the color key equals the value of this variable that we defined right here. So if the value is red, we're going to have an inline style of red now. And you can see when we go to the page now, you can see that the conditional was met. It said, okay, this is red, so it equaled red. There's actually an easier way to do it, since obviously every one of these colors is a valid CSS property. You could just simply assign the property directly without even creating a, like you could even just simply say color equals the value, right? Because every one of those values is a valid CSS color. So if we go back to the page now, you get red, green, blue, and yellow. All right, so now to make this component more reusable, whenever you have data that's like static data like this, it's typically a better idea to have the data passed into the component versus actually declaring the data from within the component, because then the component can be really muddied up and dirty here. So you would do it the same way that we've seen before, where we're like, hey, props is going to be a Fruit Loops props. And we'd have to go ahead and define that. So type Fruit Loops props equals, and then here we're going to say that fruit is going to be an array of string values. And mine just automatically closes like that for some reason. And then here, let's go ahead and take this away. And we want to reference the fruit from the props, since we know that it's going to be passed into the component. And now there can be like a centralized state. So when you start getting into like MobX and Redux and all this other stuff, or you're making server calls and things like that, that data is most likely not going to be stored within your component itself. It's something that you'd want to pass in. And now you can say, hey, you didn't pass in this fruit. It's missing the fruit loop, and it tells you when you go over it. I thought it would tell you the type, but it just says that it's missing. Okay, and either way, if you were to say, because we said array of string, like if I said fruit equals a string, then you're going to see that that's where you get the error message, and it says, hey, you passed in a string here, but we need an array of values. So I could actually just simply define the array. I'll paste that in here, and then say fruit equals fruit. And now it's satisfying the component. This could come from an AJAX call or a server or a local file system that you're just importing. We could add more values to it. What other ones? Pink. What else we got? Green, blue. What other Fruit Loop colors? I know there's no pink ones except for the stale old red ones. I think that's about all of them, right? What am I missing? Probably another, fine, brown. Oh, I have a poop Fruit Loop. All right, so now having those values defined outside, it's a bit more dynamic. It's more clean. You could get, you could separate your data from your actual components. All right, guys, so the next thing I want to show you is that every component has the ability to call code after the component is rendered. A lot of times what people do is they try to call custom JavaScript, and they try to have that JavaScript interact with a React component, but the JavaScript code is actually being called before the React component is actually mounted into the browser, and therefore when you're looking for a certain element or something like that, it's not there when the code is being executed. So to see something like that in action, like for instance, if I said, you know what, I want to do something to this element, after it's rendered. If I just put like a custom ID on this, I'm going to say my header. And now, like, as this function is executing, what if I said, you know, I want to do something? So I'm just going to say alert document query selector, and I'm going to look for my header. I want to show you what happens here. So if I refresh this page, what you're going to see is you're going to see null. So I know it's hard to see there, but it is null. That means that the code fired before the actual element was there. So how do you actually make sure that custom code gets fired after the element is loaded? And to do so, you want to actually do something called use effects, which is part of the React hooks. And what we would do is just simply reference the React library, and we're going to say use effect. And then here, you're going to pass in a function that is going to be called. And this is going to be called as soon as the component is mounted. And that way, if you needed to do some sort of dynamic behavior, you wanted to change the values, you know, you could do all kinds of stuff with it from here. But now this isn't going to be null anymore. You can actually reference it. And again, it's just simply looking for this element. And we saw that it was not there when the code was being fired before. But now this use effect code is going to make sure that it's only going to fire after this component is on the browser. So going back to the page, we refresh, and you can see that you actually have the object, and you can manipulate it and do things with it from that point. So that is using effects in React. All right, so I didn't really touch too much upon the actual debugging of React, but because we have our, where the heck is it? That's our Redux. I see. Okay, so we have this, this is our Chrome extension, and I'm glad I actually showed you guys this. What we need to do is enable source maps. HTML5 source maps allows us to debug. And right now you can see when we click on the React tools, it says this page doesn't appear to be using React, and it's because we didn't tell Webpack to actually use source maps. So to add a lot more debugging capability, let's go back to our Webpack config. And we can just put it after the entry element here. But what we're going to say is dev tool. And we're going to say inline source map. All right. And we're going to have to restart Webpack. So Control C should stop it. Press Y. Run our build command again. And this should now generate the source maps that we need for debugging. Oh, interesting. So it's not related to the source maps, which I'll touch on in just a second, which you do need for proper debugging. But check this out. Like it says that by default, when we're running this from our file, which is what we're doing here, you can see it's just a simple file. You have to go into your settings extension within Chrome. So I'm going to go here and go to my settings. And then if you click on extensions and you click on details here, you can see allow access to file URLs. So we want to go ahead and turn that on. And now by doing that, this is now picking up on the fact that React is there. So that's news to me. I didn't realize that. I might even have to, well, I just have to click on that joint. All right, so restarting Chrome did that. Okay, so now I can actually click on the components. And what I wanted to show you here is that, like, if you right click, and you go to your components, like these are all anonymous. They don't have a name, but you can see the actual props on them, right? All right, guys. So for the React developer tools, it seems like it really hasn't been updated, in my opinion, in order for it to use some of these functional components. Like it used to use reflection in order to figure out the component name. In this case, it can't. It thinks it's all anonymous. And it's usually helpful to figure out what type of component are you dealing with. You don't want to see a bunch of anonymous components. It's not very helpful for debugging. So in order to fix that, what we have to do is we have to explicitly, on the name of our component, reference this display name property. And then I would just simply give it the name of whatever the component name is. And we should do that for all of our components here so you can actually see. So again, custom date dot display name equals custom date. And it would just be helpful to do all of this stuff here. For every one of your components that you create, so that way it just makes it easier to debug and figure out what you're doing. And like I said, I think, this is something they're actually in the process of redoing. Last I checked, the Chrome developer tools, and I don't know. This seems rather, I would say, verbose and unnecessary, but it's something we have to do. We didn't used to have to do that with class-based components, but I'm not trying to complain about it. All right. So now by doing that, if we refresh, we now have the custom elements here. So we can see when we click on header, we got props that are being passed in. I wish you could change this on the fly, but you can't. Custom date, no props passed in. Fruit, you can see all the different fruit that we passed into it. So it's actually helpful for debugging. And then going back to the source maps that we enabled for Webpack, I just want to show you, if you go to your sources panel and you go to your Webpack, since we're creating the source maps, what you can do is we're actually running this bundled JS file, and this stuff isn't legible. This is what Webpack created for us, and it's in TypeScript as well. It's TypeScript code being converted to all this stuff, but you can't really debug this stuff very well. So that's why we turn on source maps, and you can actually go into your source here, and you can see all of the files as they exist, and we can just go ahead and simply put some debugging on there in order to see. So certain things, like if I do put a breakpoint there, and you can hit the breakpoint, you can see the props in real time and stuff as it's being passed in. So it makes things a little bit easier to debug, but not really trying to get in too much into the source maps. That's something you'll have to read up more about. All right, guys. Yeah, I'm pretty tired. It took me a long time to do this series. I'm trying to get back into the swing of things with tutorials, and I plan on coming out with a lot more. So there's going to be some more stuff I want to talk about with you guys when it comes to React. It's going to be about like dealing with state management with Redux and also with MobX. I'm going to start with MobX so I can show you guys how to do a state system. And we're also going to get into some data scraping tutorials and things like that, so you guys can even build a full-fledged website by collecting data, analyzing that data. We're going to use Python and a few other things in order to do that. But ultimately, all these tutorials are going to come together so you guys can kind of get up to speed with what I know. And honestly, you'll be well on your way into hosting your own website. Like this is my website here, CodeHawk. It's mostly just for a portfolio-based thing where it's like, hey, contact me if you guys want, if you're interested in getting work done, things like that. But every developer should have their own portfolio website, and I really think that you should host it yourself. So I use Linode, which is a sponsor to this channel, and they're a great company as far as being able to save a lot of money for my hosting needs. And there's also a newsletter, so if you guys are interested in more stuff from Chris Hawks, if you guys want to be up to speed, I get discounts from different products and things like that. So a lot of times it's like free trials and other stuff, and I don't necessarily want to talk about it on my videos, but sometimes it is good to get in contact with you guys to talk about some of the latest stuff. And also, if YouTube ever went away, that I'd still have a way to reach out to my audience. So make sure you guys sign up to my newsletter. So if you go to codehawk.com, you're going to be greeted with a pop-up that's going to ask you to subscribe to my newsletter. And if you guys could definitely check that out, the link is in the description tab below. Also, again, if you're looking for hosting needs, check out Linode. And if you guys have any questions or anything, feel free to leave a comment. Let me know what other tutorials you guys are looking for. And the code is also going to be available on GitHub, and that link is also in the description tab below. All right, guys, I hope you guys enjoy this journey. And from here, what you got to do is build your own components. Build a component for looking at a YouTube video. How do you pass a URL to your video component so that you can just pass a bunch of different URLs in an array like we saw in this series? There's so much you can do with what we've covered, and it's enough information where you should just be able to spend weeks, if not months, just kind of going over it over and over again, not really watching the video over and over again. I don't think it's going to be necessary. Probably use it more as like a reference, and just start building your own thing, because that's going to be the fastest way to learn. And also make sure you guys smash that like button, like everybody's saying these days. So annoying. But yeah, I need you guys to like the video if you would. Also share if you can. And I know that's a big one to ask people to do, but it helps the YouTube algorithm. It helps me out. And yeah, definitely subscribe. All right, guys, thanks for watching. Have a good night. Take care. Bye.